Hello, good afternoon, everyone. Thank you for joining the live stream. Just wanted to check if we are audible on YouTube. Thank you for the confirmation. Good afternoon once again. Today's session is hosted in collaboration with Ansys. Today's speaker is Mahendra Joshi, lead technology specialist at Ansys. He will host a session on Ansys Automotive Solutions Overview. Over to you, Mahendra.
Thank you, Renita. So, good afternoon, everybody. So, for next maybe 45 to 50 minutes, we'll go through the how ANSYS can offer you to better design the automotive systems and subsystems. And at the end, we'll take some Q&A if time permits. And if you have any questions, do type them in chat window. We'll try to answer in the due course of time. And if we are run out of time, we'll try to get back to later. So this is the brief outline for my today's presentation. So first part is, am I audible?
Yes, Mahendra.
Okay. Yeah, so first we'll talk about the couple of challenges in the automotive industry and how ANSYS can offer the solutions to address those automotive engineering systems or subsystem designs. Then there are lots of new mega trends are coming like electric mobility or autonomy, as well as the software-defined vehicle. So we'll also try to cover how ANSYS can also help to those OEMs who are in the business of e-mobility or SDV. And we'll also talk about the newer emerging trends, where like the artificial intelligence or machine learning, how those can be also leveraged to design the better products. And at the end, we'll conclude. So if you see the typical challenges for the ground transportation vehicles, so performance and is the key attribute. And when we talk about performance for traditional vehicles, the which are internal combustion engine powered, so fuel economy plays a vital role. And there are lots of norms are coming, such as the Environmental Protection Agency's corporate average fuel economy or European Union's fleets average 2030. So these mandates that the fuel economy for certain class of vehicles should be within the certain range. If the vehicle is a electric type, then the more and more range is always desirable. So these are like performance attributes. On top of that, there are lots of pollution regulations are coming up, like European 60 or CARB laws or the Environmental Protection Agency's laws. So these basically are mandated from the perspective of the Paris Treaty, as well as the reducing our greenhouse gas contribution, so that we can reduce the global warming effects. And apart from the performance, we also have the safety requirements because of the passenger comfort, and where there are lots of new ratings are come up, like European NCAP or just normal NCAP or 5-star rating. So those basically also parameters will decide whether the vehicle is safe enough to drive on the highways with a certain speed, or there are chances, because especially in India we know that a lot of fatalities are occurring because of the roadside accidents. So safety is now becoming a key attribute in the selection of the automobile. And all these performance and safety features needs to be integrated in the vehicle at the lowest possible cost. And all the systems are now coming with lots of electronics parts. So EMIMC also plays a crucial role, and all these development should happen in the shortest possible time. So traditionally, it used to be a couple of or 3-4 years was the time for development. Now the requirement is that it should be as shortened as possible within the couple of years, so that it can be launched in the due course of time with the first time right. And nowadays, with the introduction of the Paris Treaty, the sustainability is also gaining a lot of momentum, and the reduction of the greenhouse gases or the CO2 emissions from the vehicle that is indirectly affected by the fuel economy or the range of the EV. If we have more range, automatically the sustainability goal will be achieved. So that also now becoming an important parameter in the automotive transportations. Now, when the as a part of the automotive manufacturer, the requirement here is that the requirement is to speed up the design cycle so that the product can be launched faster in the market, and at the same time it should be innovatively designed so that the new and unique characteristics should be exhibited by the product so that there will be a competitive advantage of this feature over the contemporary competitor so that there will be the better acceptance by the customers because of these unique selling points. And at the same time, when we are developing the product faster, that means we are compressing the development cycle and we are making the products innovative. We should also keep the tab on the development cost so that it should not increase the development cost too much so that it will eventually increase the burden on the customer. So we need to make sure that the targets related to the cost or the weight or the size and sustainability are pretty much met without increasing the overall cost of the vehicle. So for that, the digital transformation will play a key role, and especially the Ansys simulation solutions will definitely help to address these automotive challenges. So if I just quantify a couple of benefits which customer would have seen by using the simulation in the development of the ground transportation vehicles. So one is the gain in the performance. So if we have the best practices employed and if we have the optimize the settings, optimize design practices, then it will help us to increase the simulation productivity. That means that in the same span of the time, the customers now can perform the more and more simulations. That means the customer now has the flexibility to evaluate the multiple designs in hand and all the possible scenarios before the product is getting manufactured or before the first prototype is getting built. So that will help to get optimal solutions, and that will also help to reduce the product development time significantly. So another benefit the customer can see using the simulation is a significant reduction in the product development cycle or design time. So one of the customer who is designing who is based off the North America and who is in the business of the engine manufacturing, they could employ the simulations and they could able to design almost multiple design iterations upfront within the days time instead of the months time, so that could able to speed up their product development cycle significantly and without compromising the quality of the product. And third use case is basically from one of the two-wheeler manufacturers based out of the North America. Basically, the objective was here to make the lightweight so that its high-speed performance will be retained. So we know that if we have to gain the higher speed, the weight should be as low as possible. So the requirement here was to reduce the weight of the vehicle significantly by using the topology optimization technology in the ANSYS. The 56% material was eliminated, and that could result it into the significant weight reductions, and that means the better performance of this motorbike. So in addition to these three use cases, so there are multiple other avenues out there for a conventional as well as the electric powertrain vehicles to have the better innovation with the lower cost. So if we see nowadays, there is a lot of momentum for the EV cars, and typically EV cars are having the batteries as well as e-motors. So the how efficiently we can choose the battery packs and how we can manage the thermal management of these batteries, that plays very crucial role in the safety as well as the performance of the electric vehicle. And we know that these electric vehicles will have the e-motor as the powertrain source. So the optimum design of the electric motors using simulation also play crucial role. And we can also employ the simulations to make the lighter vehicles so that when the vehicle is lighter, basically its speed will be higher, but at the same time we should make sure that the safety is not compromised. So by using the additive manufacturing technique, we can design the lightweight components, and at the same time we can make sure that the safety is also intact. So the vehicles nowadays needs customer requirement is that the noise emission from the vehicle should be as low as possible, because that is one of the luxury, or one of the comfort parameters. Is no more now luxury, but the noise comfort is one of the key attributes in case of the automobiles. So by using the simulations, we can improve the NVH design of these automobiles. We know that a lot of electronics is now taking part of the modern automobiles. So we should make sure that the chips which we use for the electronics, they are intact and they are delivering the superior performance. At the same time, now lots of connected vehicles are coming up in the market. So there the 5G networks are getting used. So uh, we need to make sure that the communication between the two adjacent vehicles and between the tower and vehicle is intact. So we can study the integrity of the signal using the ANSYS simulation technology. And the traditional approach of reducing the drag is always welcome, because it will help to increase the range of the EV or electric vehicle, or it will help to increase the fuel economy of the vehicle. That means the better sustainability and lower greenhouse gas emissions. And in the all autonomous vehicles, or ADAS vehicles, or advanced drivers assistance system vehicles, lot of sensors are getting employed, like radar or lidar. So we need to make sure that the sensors will work in all the weather conditions, whether it is rainy or whether it is soily environment. So it should work perfectly, so that the performance is not compromised. Now, in case of software-defined vehicles, or when the softwares are, lots of softwares are getting employed in these autonomous vehicles, we need to make sure that the softwares are safe from the cyber attacks, so that it is not jeopardizing the safety of the passengers or co-passengers who are inside these autonomous vehicles or software-defined vehicles. So these are the few avenues where simulations will certainly help to have the better innovative products, but at a lower cost. So let me now go one by one about how ANSYS can help to better uh, design the automotive systems and subsystems. If I broadly categorize the vehicle engineering, it can be classified into four subcategories. First is a exterior part. One is the interior part of the automobile. Next is the chassis. Then next is the powertrain, and the last one is electrical systems. So when we talk about exterior systems, it covers the aerodynamics part, then external aeroacoustics part, as well as the vehicle thermal management, then the dirt and water management, especially, and lastly the structural integrity. So when we talk about the interior aspects, it all covers about the thermal comfort which is required by the passengers and co-passengers which are sitting inside the car, and crash worthiness of the vehicle is also very much important, because whoever the passengers are occupying the car, they should be safe enough in the any kind of the eventuality. So if there is any frontal collision or there is a side collision, the passenger safety should not be compromised. And there are lots of electronics gadgets or electronics displays are seen in the modern automobiles, because more and more electronics is taking part in the electronics which is required for the performance of the vehicles. And entire vehicle is built on the chassis, so chassis structural integrity is also equally important. So we'll cover these aspects in detail in the subsequent slides. So coming back to the first part about how the simulation will help to have the better exterior component performance. So when we talk about the exterior systems, mainly we talk about the aerodynamics, aeroacoustics, thermal management, and dirt management, and water management, and the structural integrity. So we can use the ANSYS CFD solutions, especially to optimize the drag coefficients or to reduce the drag coefficients so that the fuel economy of the conventional IC engine power vehicle will be improved. And if it is a electric powertrain vehicle is there, then automatically the lower drag means the range of the vehicle will be yours. That means that there will be less parasitic losses and the vehicle range would be increased. And with the introduction of these worldwide harmonized light vehicle test procedures, it is important that all the multiple configurations of the automobiles should be evaluated upfront and should be reported for the drag coefficients, which will affect the cafe a corporate average fuel economy or the overall fuel economy. So using the simulations, we can study these drag coefficients and we can also optimize it. And we can also identify the regions which are causing the high drag in the vehicle so that we can take the corrective actions. The next is acoustics. So acoustic is also a very important attribute in the selection of the automobile, especially in the passenger cars. And there are norms are coming up like the pass by noise or as well as the passenger comfort parameter is decided by the noise which is coming from the engine or as well as from the external components. So we can study this aero acoustic aspect of the noise using the CFD simulations, and we can quantify the noise sources and we can take the corrective actions to reduce the aerodynamic noise. So we can use the alias kind of simulations using the Ansys Fluent, and then we can calculate the noise at the distance. If it is inside the vehicle or it is at the co-passenger level, we can estimate using this computational or acoustic approach, and we can calculate the sound pressure level at the receiver locations and to make sure that the sound pressure level is within the acceptable limits. Next is the requirement is the thermal management. So when there is a vehicle is there inside the vehicle under the hood, there is an engine and engine is being the hottest component. It can radiate the heat or it can convect the heat to the adjoining the components which would be made up of the plastic or could be made up of the rubber. And if the temperature exceeds the certain specified limit, then those components can underperform or those can get damaged and needs to get replaced. So the objective of this under thermal management study is to see the temperature of the adjacent components around the engine and to make sure that temperature is not exceeding within the specified limits. So to provide the adequate cooling is also another requirement for the underhood thermal management system on the front end airflow systems. So using the conjugate heat transfer simulations in the ANSYS plan, one can evaluate the underhood thermal performance or under thermal management of the vehicles and study whether it is adequate enough or needs any improvements. The next part is the management of the dirt or the vehicle soiling part. So especially when there are lots of sensors are there, especially in the vehicle for the efficient operation of the vehicle. So important that we study the whether it is impacted by the dirt or all the adverse environment that it's able to handle or not. So we can perform the multi-phase simulation using the ANSYS technology, especially Ansys Fluent, to study the trajectory of the soil particles or the water droplets to see whether water is reaching to the sensors and whether it is blocking the path or whether it's causing any damage to the sensor. So those kind of scenarios will be easily evaluated using the ANSYS simulations. And especially if there is some film formations happening, so we can also quantify the extent at which the film is getting formed on these vehicles and on the sensor surface because it can affect detrimentally the performance of the sensors. So it is important to evaluate whether the sensors are performing better in all the conditions or not. The next aspect we can study using the simulation in the vehicle engineering is the structural integrity or structural rigidity. So that can be studied. So that can be easily studied using the simulations like ANSYS Mechanical. And the objective here is that whether we are able to optimize the weight and indirectly cost without compromising the safety of the passengers. So we can perform the and structural integrity simulations using some mechanical or the crash simulation as well. And we can study the durability of these components also. So next aspect is the interior vehicle engineering, so which is comprised of the climate control, cabin acoustics, crash, and ergonomics. So when we talk about climate control, it is nothing but the vehicle's HVAC systems or heating, ventilation, air conditioning systems, which is essential for the passenger comfort, especially when we are going in the colder geographies or colder weather. So it should be it should provide adequate heat, or when we are driving the vehicle in the hot summer, it should provide the adequate cooling so that passengers should not feel the heated environment or too much colder environment. So that can be addressed using the typical HVAC systems, and especially when we are driving the vehicle in the rainy seasons, we see that some kind of the fogging will happen on the front uh, glass, and if that is not cleared up, then it can affect the visibility and there's a possibility of the accident. So defogging, and especially in the cold environments like where the snowing is happening, so de-icing is also very important attribute of this HVAC system. So using the flow simulations, we can study the effect of the quality of the air, as well as we can study the temperature near the seats which passengers will experience, and accordingly we can modify the design so that we can get a better air quality as well as better temperature control around the passengers, and we can also make sure that the defogging and de-icing system is working as expected. Next part is again related to the acoustics. So like the passengers which are inside the car, so they will experience the noise because of the side mirrors or because of the external flow. So those noise will be transmitted to the glass panels and eventually heard by the drivers and co-drivers. So by using the deterministic aerovibroacoustic approach, we can study the how noise is getting generated external to the vehicle and how this noise is getting propagated from exterior of the vehicle to the interior of the vehicles, and we can estimate the sound pressure level at the passengers and co-passenger levels, and we can adequately take the corrective actions to reduce the noise if it is more than the specified limit. So we can get all the sound pressure level parameters and the location of the noise sources using the simulations. Another important aspect I mentioned earlier was a crash worthiness. So passenger safety is paramount, especially in case of automobiles. So in the event of any frontal collision or side collisions, it is important that the airbags will get opened in the adequate time, and passengers will be not having any major damage. So that is the goal of the this crash worthiness. And by using the simulations like LS Dyna, of we can check whether the crash worthiness of the vehicle is adequate or needs any kind of the design modification. So we can perform the optimization of the weight without sacrificing the safety of the vehicle. So that kind of studies we can perform using the simulations, especially the LS Dyna kind of simulations. And these crash tests are very costly in nature. So if we have typically manufacturers having hundreds or multiple variants, so testing each variant will increase the development costs. And basically, once the vehicle is damaged, it is can no longer be salvaged or no longer can be used. So it is like a destructive testing. So by using the simulations, we can minimize the number of such expensive physical testing. So next part is the ergonomics. We know that lots of electronics are there, lots of now infotainment systems are there, and nowadays days are gone that we are having the only the analog displays. So nowadays all the displays are like digital in nature. So it is important that this human machine interface or HMI displays or head-up displays are ergonomically correct so that the driver as well as the co-driver people can easily read the messages which are displayed on the screen. So it's important to make sure that the ergonomics is handled properly and the messages are read properly so that there will not be any consequences of misreading or misinterpreting the data displayed on the screen. So that will help to minimize human errors. So using the optical solutions provided by Ansys, so one can evaluate the multiple scenarios of the head-up display or human machine interface, and that way it will help to design these systems more efficiently and more effectively. So next aspect of the vehicle engineering is the chassis. So chassis is comprised of entire body where the different systems or subsystems will be hosted. So important aspects in the chassis design is the structural integrity of the chassis. Again, the crash worthiness of the chassis in case of the accidents, the deep painting or deep coating of these vehicles before uh, they are delivered. So painting activities performed the vehicle. So effectiveness of painting can be also studied using the simulations, and the performance of different subsystems such as the steering or suspension systems or the brake systems can be also evaluated using simulations, and especially the lastly about the wheels and tires also can be studied using the simulation tools. So first we talk about the structural integrity of the chassis. So important that we maintain the adequate strength to the vehicles without over designing these vehicles, and at the same time we can optimize the weight so that it will not increase the cost of the vehicles and it will not have the adequate tooling cost, adequate metal cost. So we can also appropriately choose the material for the specified performance using the simulations. And we can also study the effects of the wind loads or the fluid structure interaction aspects can be also taken into considerations when we are designing the chassis. So next aspect of the chassis design is the crash and safety. So as I mentioned earlier, so like interior design of the interior safety of the co-passengers or drivers. So it is important that the when the event of the side collision or side impact or frontal impact, vehicle chassis is sufficiently resilient enough so that those collisions will be absorbed by the chassis itself and the passengers inside the vehicles will be remain intact. So using the simulations, we can study all these aspects, and again we can certainly say on the reducing the expensive physical testing. And in terms of the vehicle subsystems such as brakes, suspension, steering, we can study the thermal aspects of the thermal aspects of this vehicle, brake systems or suspension systems, and that way we can basically see whether during the braking systems whether the heat generated is dissipated adequately or not, or it can have the durability challenges if it is not managed properly. So all these scenarios can be studied using the simulation techniques. And apart from the thermal performance, brake squeal is also another attribute we can evaluate using the simulation, because that unwanted noise, which we call as a squeal, can be also calculated using the simulations, and it can be addressed using the simulation techniques. So next aspect about the chassis is the painting part. So the painting part especially is important to study that whether when the vehicle is going for a deep painting, whether there are any formation of air pockets is happening or not. But if there are any air pockets, then the quality of the paint will be inferior on that region, and there could be some blind spots can occur, and that means there is a rework required. That means it will reduce the throughput of the production line, and that way it will reduce the total number of vehicles produced in a given span of time. So to increase the manufacturing productivity, we need to make sure that this manufacturing process are optimized enough and they are efficient enough. So we can study this painting process using the simulation technology like the multi-phase simulations and as well as the thermal thing. So we can study whether the any dead zones are getting formed or any air pockets are getting formed, and how much time it is taking for performing this deep painting activity, as well as how much time it is taking for getting this paint dried up by using the thermal one part. So all these aspects we can study using the simulation. So especially when we are designing the wheels, rims, as well as we can optimize these wheel rims for the better weight, and then perform whether the material is good enough or whether the performance of tire, like the contact patch, is good enough, and if there is a rolling resistance is appropriate, and this footprint. All these studies can be performed, especially like the noise generated because of the hydroplaning effect or the inflation of the tires or the rolling. All these aspects we can study using the simulation. The next aspect is related to the powertrain of the vehicle. So typically in the conventional powertrain, we have the internal combustion as the main the source of the power. And in case of the electric vehicles, the electric powertrain or e-motors is the source of the power. Despite whatever is the source of the power, transmission would be required. And if, especially if the conventional powertrain driven vehicle is there, then we need to also have the fuel systems as well as the exhaust systems and after treatment, because whatever the exhaust which is coming from the engine cannot be directly discharged in the atmosphere in order to meet the noise regulatory norms. So when we want to design the superior internal combustion engines, so objective here is that the efficiency of the engine over the different speeds is good enough, and we can study that aspect using the Ansys simulation solution called Forte. We can also study the certain unwanted phenomena such as engine knock or engine noise using this simulation technique. And we can also study the, if we use the different fuels, how the suitability of that fuel and how much the power it will generate and what could be the consequence of the noise norms. So when we have different alternative fuels, so we can always study the effectiveness of the alternate fuels in terms of the efficiency of the engine, in terms of the pollutant emissions, as well as in terms of the other detrimental parameters like knock and the noise generated. So those kind of studies we can perform upfront before we perform uh, the engine test bed test. Another aspect of the powertrain is the design of the efficient transmission system. So, what are the losses are encountered in the powertrain? So, those are nothing but affect the fuel economic vehicle, and eventually that will increase the greenhouse emissions, or it will affect the range of the electric vehicles. So, we can estimate these different churning losses or viscous losses using the simulation techniques, and at the same time, we can also estimate the noise generated because of the mating gears as well as because of flashing. So using the NVH tools of the ANSYS. So all these studies we can perform using the ANSYS mechanical and ANSYS CFD solutions. So in case of the conventional powertrain driven vehicle, so it's important to make sure that what are the fuel systems we are employing, so it is efficiently enough, and we what are the fuel is injected in the combustion chamber, it gets atomized properly before it mixes with the air, and then it will directly affect the combustion efficiency of of the engine, and indirectly it will affect the fuel economy of the vehicle. So what are the power is generated out of this engine, that is a strong function of how good the fuel air mix is, and that indirectly affects how good the atomization takes place. So we can study the effectiveness of the atomization in the simulation techniques. We can also study the how what is the flow rate of the fuel system pump, which is delivering the fuel from the fuel tank to the engine. So all these aspects can be studied, and that will help us to estimate what are the losses and what is the effectiveness of the, or what is the pump efficiency. So all these aspects we can study. So one is the efficiency aspect, and another is the noise generated because of the operation of the pump. So by using the simulation, we can also estimate how much is the noise getting generated by the operation of the pump. So that is also another important aspect that can be studied using the simulation. Now, in case of conventional powertrain driven vehicles, it is very much necessary to employ the after treatment devices, because in case of petrol engines we may use the three-way catalytic converters. In case of diesel engines we need to use the selective catalytic reduction to reduce the NOx, as well as diesel oxidation catalyst to reduce the hydrocarbon emissions or carbon monoxide emissions. So how effectively those systems can be designed, that can be studied using the simulations. And what these are the high temperature exposed machines or high temperature exposed equipment. So these are exposed to thermostresses, and because of the thermostresses, the structural integrity can be compromised. So it is important to evaluate the structural integrity and durability of such systems before they are productionized or before they are employed in the actual vehicle. So using the simulation techniques, especially we can perform the conjugate heat transfer simulations to get the temperature map of these components to see how much is the light of temperature, whether the light of temperature is sufficient enough. And we can also use this temperature map to calculate the thermal distortions and whether the thermal distortion is causing any structural issues. So those effects can be studied using the simulations. Apart from the thermal performance, we can also study the noise performance, because if there are some silencer parts are there in the exhaust systems, we can design this effectiveness of the silence systems by using the NVH solutions from the Ansys. In case of EV or electric vehicles, so electric motors are used as the source of the powertrain, and we can study the cooling of these motors by using the simulations. We can also study uh, it can be direct cooling or it can be indirect cooling. So whether the motor cooling system is reliable enough so that the motor windings or basically the motor magnets are not exposed to very high temperatures, because if they are exposed to very high temperatures for prolonged time, it will affect its performance significantly, and eventually it can result it into the loss of the performance, such as the loss in the torque or loss in the range of the electric vehicles, or efficiency also can be reduced. So that means overall the fuel economy is reduced. At the same time, this motor can generate also the noise. So the noise will have the customer uh, comfort parameter. So if noise is very high, then it will affect the customer's comfort level. And again, we need to optimize that for the better noise characteristics. So all these, like the temperature history, or we can study also the motor noise using the ANSYS simulation techniques. So we can perform the CFD simulations for estimating the temperature on the different components of the motor. At the same time, we can also study the electric motor using the ANSYS Maxwell tool to study the forces, and then we can use those force information for the image signature estimation. So all these effects can be studied using the simulation. Now coming back to the last aspect, which is the electrical systems. So lots of electric wiring harness and connectors are the part of the modern automobile, and we can see that now infotainment system is also playing a very important role, and that's very much critical in the all modern automobile systems. And advanced driver assistance systems, as well as the sensors used in ADAS or autonomous vehicles, needs to be also evaluated critically. And since there are antennas will be there on the vehicle, especially to communicate between the tower and the given vehicle, as well as the between the two adjacent vehicles. So the placement of the antenna or the performance antenna also plays very crucial role in the design of these such vehicles. And finally, the reliability of such electric systems is very, very important for the consistent performance of such vehicles. So by using the Ansys simulation, we can study the wiring harnesses, especially we can study the electromagnetic interference or electromagnetic resistance, basically using the Ansys electronic solutions. And we can study whether there is a crosstalk or whether is a radiation is there, electromagnetic radiations, or how much is the susceptibility, how much is the immunity. So all these aspects can be studied using the Ansys electronic solutions. So these parameters are very much important to design the shielding effectiveness. Now, next part is infotainment. Infotainment system is nothing but a printed circuit board where there are lots of the chips will be there. So if and it will carry a lot of electric current. So if it will generate a lot of heat, and if it is not managed properly, eventually there is a chance that this printed circuit board may get overheated or it may get bent because of the non-uniform heating and the distortion because of the high temperatures. So that so by using the simulations, we can study the chip level, package level, or all. So using the simulation, we can study the power integrity as well as the signal integrity, and we can estimate the parameters such as S parameters or the resonance aspects using the simulation. So next aspect is ADAS or the autonomous vehicle. So here important consideration is that any kind of eventuality in case of any inclement weathers or lighting conditions like snow, rain, or night, it should perform effectively and it should enough. So all these sensors are primarily placed on these vehicles to study the different parameters. So they should perform without any deterioration performance at all the weather conditions. So that is a requirement. So using the simulations, we can uh, see all these aspects, and we can make sure that we are not getting the wrong signals and we are not getting the incorrect. So they are performing as as expected. So especially in case of connected vehicles, the antennas are very much critical, and the antennas play a very uh, crucial role, especially in the communication between the tower and vehicle as well between the two adjacent vehicles. So by we can perform this placement of the antenna, and we can also study the radiation pattern of the antenna using the ANSYS electronic simulations. So that will help to see whether the gains of the this antenna are good enough, or we need the multiple antennas, or we can work with a single antenna. So all these aspects can be studied using the simulation techniques. Now, lastly is electronics reliability. So especially electronics reliability, especially in terms of the power integrity and signal integrity, is very, very critical. And objective here is to increase this power integrity and signal integrity. So we can study this DCIR losses, or we can also do the chip package system analysis using the um, ANSYS AM solvers to see whether signal integrity and power integrity is as per the expectations or not. So these are the different outputs we can get from the simulation, electromagnetic simulation like EMI, EMC, or S parameters, or the I diagrams or waveforms. So this will help to electronics engineers to make sure the effectiveness of the this electronic system is not compromised and it is as high as possible. So these are the couple of customer success stories where customer could able to increase simulation productivity, especially this the use case by the Ferrari, which is famous for this basically the Formula One racing as well as the motor car racing. So by using the simulation, especially this Ferrari will evaluate three times more design iterations within the same span of time. That means they could optimize the designs in more faster way, and they could get the right solutions in the first time approach. Then next is the effective engine cooling system design using the simulation. So this customer again based out of the this is it's based out of North America, and by using the simulation, they could able to increase the efficiency of the petrol engine as well as the diesel engine compared to the contemporary vehicles or the competitors. And this is done by using the simulations, and they could able to evaluate the multiple designs upfront before prototype was built. So that way, their product development cycle was reduced from years or months to the days. That means, again, this will help to compress the product development cycles and to launch, accelerate the time to market. And this is the case which I was talking earlier about is the optimizing the weight of this motorcycle so that its high speed performance is not compromised. So by using the simulations, especially the topology optimization of Ansys mechanical, this customer could able to reduce the weight of the vehicles by almost 56% by using this carbon monocoque frame and optimize it using this topological optimization technique of the Ansys. So that way they could able to make the entire vehicle almost 56% lighter than earlier. That will be a significant number. Now, in addition to this conventional vehicle engineering, we can see there are lots of mega trends are there. So now all the modern vehicles, there are lots of customers or lots of automobile engine manufacturer, original equipment manufacturer companies are working on these ADAS or autonomous vehicles or e-mobilities. So there, the computer plays a vital role, and electrical plays more and more crucial role. So when we are having lots of electronic sensors are there, a lot of electrical systems are there. So these are the important aspects needs to be considered, like the 5G connectivity or communication, Ethernet communication, or cyber security. Because in case of software-defined vehicles, entire vehicle is controlled by the software, and we should make sure that it is not susceptible to any cyber attacks. And whatever the cyber attacks takes place, basically the fail-proof system is there in place. So all these aspects we can study using the ANSYS simulations in addition to the optimizing the material technology, making this lighter or using the composites or using the safety of the pedestrian as well as active. So all these aspects needs to be considered for all the modern vehicles. So and if we see that there is now a multidisciplinary problem is now being addressed. So there is electrical, there is electronics is there, then there is a mechanical systems are there where we are want to optimize the drag or weight. We want to use the composites and we are having software. So that means there will be multiple departments will be involved in the vehicle developments, and collaboration between these departments is very, very important for the first time right philosophy. So by using the simulations, we can make sure that we can have the better products at the end. So if we see these mega trends, so now the latest mega trends are like electric mobility or advanced driver assist systems or autonomous vehicles as well as software defined vehicles, and all the automobile companies are seriously experiencing this cost pressure. So when they want to integrate lots of the new capabilities or new features in automobile vehicles, at the same time, the cost should not increase. And the different departments are working for the development of the vehicles. So we need to make sure that there is a close collaboration between the different departments, and all the different scenarios are getting evaluated upfront before we productionize that vehicle. So that means, and at the same time, the development cycle also needs to be compressed as much low as possible. So speed of the product development should be high. That means we need to have the better priority in the design stage, and we need to meet the norms as well. So all these aspects needs to be can be addressed using the simulation. So we'll see that in the subsequent slides. In case of software defined vehicles, so typically the main challenges is that we need to evaluate the different design scenarios, and verification needs also important. So before physically testing that vehicle, we need to evaluate these scenarios using some kind of a virtualization or some kind of virtual simulators, because every time we cannot deploy the actual physical prototype to test the scenarios, that will increase the overall development cost. So this verification design complexity needs to be addressed in the case of the software defined vehicles, and using the simulations, especially like model based system engineering, we can do lots of virtualization, and we can choose this better architecture of the electrical systems. And especially ANSYS offers the uh, basically well proven the or foolproof systems to develop the embedded software system code, which will be meeting the compliance norms, and especially the uh, chip PCB board also that can be studied. And cybersecurity is very, very important in case of software different vehicles. So all these aspects we can study using the simulation techniques. So this is one of the success story by the company called Robert Bosch, where they use the kind of open platform system architecture like Covesa, especially to optimize the or to increase the range of the vehicle by optimizing the battery range. So by using the ROMs or digital twins of the entire vehicle, we can quickly optimize or evaluate the designs as compared to conventional 3D simulations. Then we can also integrate the different attributes from the cloud to the digital twin using this vehicle API Covesa. So that was done by these customers, and especially this helped this customer to have the better um, uh, improvement or better inroads in the software defined vehicle development. So if we see the in case of software different vehicles, so typically the different aspects we can study using the simulation, like the reliability of the automotive electronics. A lot of sensors will be there, a lot of electronics will be employed when we are controlling the movement of the vehicle or operation of vehicles. So reliability of the automotive electronics is very, very crucial. Then since it is a software driven, entire thing is controlled by software, so functional safety is very, very important. So all the in her scenarios, basically the functional modes of the failure or different failure modes needs to be studied upfront before we uh, productionize this vehicle. And for that, especially when we are using this embedded software systems, we need to make sure that whatever the code is generated by this embedded software is compliant enough as per the global standards like IEC standards or electronic standards. And last thing is the placement of the antenna and design of antenna can be also studied using the ANSYS simulation techniques. Another new mega trend is electric mobility. So this electric mobility where the electric motors are used as a source of power and for the powertrain, and so the power is coming from the batteries. So we can studies different aspects of the this electric vehicles. One is the battery manufacturing process or the thermal management of the batteries, then or fuel cell performance if it is a fuel cell powered vehicle. So to see whether the output from the fuel cell is good enough over the state of the charge conditions. And we can also employ basically the multi-objective functions, especially in case of the design of the traction motors, to make sure that for different speed range, the torque provided by the motor is as per the expectations. So we can study the structural reliability, we can study the thermal aspects, we can study the electronic performance of the electric motors using the ANSYS Maxwell or ANSYS mechanical or ANSYS CFD solutions. So all these different aspects of the electric mobility can be very well studied and optimized using the ANSYS solutions. So this is one of the success story of the ZF, which is one of the major automobile manufacturer in the Europe, and especially they are designing electric motors. So using the simulations, they could able to evaluate the fluid and thermal and electric performance at the uh, virtual stage before they built their first prototype. So by using the simulations, they could able to attain the overall efficiency of this motor system almost 95%, which is a significant number. Another megatrend which I spoke was the advanced driver assistance system or autonomous vehicle. So especially in case of autonomous vehicles, it's very important that it's a driverless vehicle. So it should able to detect the obstructions very clearly without intervention of the co-driver, the intervention of the passengers. So we need to evaluate all the scenarios upfront in case of the virtual world. So that can be studied using the simulations. We can evaluate all the scenarios. We can study the location of the radar or lidar. We can see whether they are effective or not using the Ansys electronic solutions. And we can also study the lidar performance, which is nothing but the eye of the autonomous vehicle. So all these different aspects of autonomous vehicles can be studied using the simulation. So this is another use case of the BMW where we work collaboratively with the BMW to develop the solution called AV Accelerate, which will help to evaluate different scenarios which are required for L2 or L3 autonomous vehicles. So, so that will help to evaluate different scenarios as well as the performance of these autonomous vehicles effectively. Last aspect of the this is the mechanical systems optimization, and that we can do using the ANSYS mechanical or ANSYS LNR. So LSNR is specifically used for the explicit kind of simulations or the crash simulations, and ANSYS mechanical can be employed for the component level simulations. So using ANSYS mechanical and LNR, we could able to demonstrate a company called Hyundai Motor Corporation that ANSYS can address their all the component and the system level design challenges. Lastly, I would like to quickly touch upon the new and emerging technologies which can be leveraged for the product development of the automobile vehicles. The first one is the GPU. So ANSYS is written the entire new code, especially for the uh, solving the CFD simulations on the GPU cards. So the main advantage of the GPU is that we can perform the long transient simulations, which used to take the several weeks of the time that can be now completed in a days of times or few hours. So what we can observe by employing the GPUs is we can get the extremely superior performance compared to the typical the CPU based solvers. And when we are using the different GPU cards, we can see that the productivity throughput is almost 30 times or 40 times higher kind of compared to the CPU solvers. At the same time, the these are being compact in nature. The product, the energy dissipation is also very low. So we save on the hardware cost, we save it on the operational cost. At the same time, we can get the result faster. So that is the advantage of the GPU technologies, and especially when we are performing the transient simulations of external dynamics or acoustics, this GPU technology will certainly help to increase or speed up the simulation cycle. Next aspect is use of the artificial intelligence and machine learning in the simulation techniques. So ANSYS has basically the three offerings. One is ANSYS AI Place, where whatever our traditional products are like ANSYS Mechanical, ANSYS Plan, or Ansys OptiSlang. So those will be enriched with the artificial intelligence technology so that the predictability of the models will be better. In addition to that, we also have the generative design platform. We call this as the Ansys Sim AI. So where initially we train the model and then we provide the brand new design, and without performing the high fidelity 3D simulations, we get the output using this Sim AI technique. So this is for when we are having the non-parametric geometries, we can use this ANSYS AI. And third AI offering from the ANSYS is ANSYS GPT, which is nothing but the virtual assistant, the ANSYS products, basically, especially to ask very means questions related to tools or how something can be modeled using ANSYS. So those kind of the questions can be easily ask to this virtual assistant. So this virtual assistant is now very, very common in case of the all e-commerce site you might have seen. So similarly, we have to using this. The only advantage is that we do not store the data of the requester. We do not store the information which is being asked. So it is not unlike the other platforms which is, will not do the any profile mapping. So that is the advantage of Ansys GPT, and it uses the public domain information. So that is advantage. So these are a couple of, let's say, use cases where AI can be used. So one is optimization of the track, second is the lightweighting of the vehicle, and third thing is the electromagnetic solution. So it is a physics agnostic solution where Ansys AI can be or Ansys SIM can be employed. So these are the one use case where the battery thermal management performance was optimized using the SIM technique. So the advantage of SIM is it, it gives results in the minutes or less than minute time. So typically when we perform the 3D CVD simulations, it will take hours or the days of time. On the other hand, when we are having the historic data, we can make use of that data and we can feed this data to the CMAI platform, and especially it will be used for the training purpose. And when the new design or new concept is to be evaluated, so without performing the 3D simulations, we can get the performance using this CMAI solver or CMAI technique. So that is the advantage. So these are the couple of use cases like battery thermal management or inverter cooling or placement of the antenna design or bumper performance. So this is the totally physics agnostic because it is purely based on the data which we provide in terms of the geometry. So just lastly, I would like to say that basically major 95% of the top 57 OEMs are trusting on the Ansys for the automobile system designs around in terms of the supplier footprint. So almost 94% of the top global 100% of the suppliers are relying on the Ansys solutions for betterment of their products. Just lastly, I would like to summarize that Ansys has several proven solutions to address needs of the current as well as future automotive industry. Yeah, and that's it from my side. If there are any questions, I don't see any questions in the chat.
Thanks, Mahendra, for the presentation. Let's just give it a minute. If the viewers on YouTube have any questions, you can put in your questions in the chat box and we'll get them answered. All right. Looks like we don't have any questions, Mahendra. So I think we're good to wrap up the session then.
Yeah, thanks everyone for your time. Have a good day.
Thanks, Mahendra. Thank you to the viewers on YouTube. Have a good day.